Mass-energy equivalence is the most heavily verified relationship in modern physics. A small amount of physical matter contains a massive reservoir of energy. The formal relationship was established during the 1905 Annus Mirabilis by Albert Einstein. Writing in Annalen der Physik, he proved that the inertia of a body is dependent on its energy content. Converting kilograms into joules requires a factor measured in meters squared per second squared, the speed of light squared. Standard physics treats c² as a measured constant, but lacks a mechanical account for why a specific velocity squared bridges physical identity to emission. Special relativity treats c as an axiomatic input. It is defined by its properties as the invariant speed of massless particles, rather than being derived from a deeper structure. This leaves a gap in our understanding of the physical origin of the constant itself. The oscillatory dynamics and topological bifurcation theory, or ODTBT, provides a recursive scalar field framework to resolve this structural gap. Within this framework, C manifests as an emergent resolution rate of a deeper coherent substrate. The derivation begins with the ODTBT Lagrangian density, which governs the evolution of the recursive scalar field. The final term, lambda, represents the lock potential. This suppression barrier dictates the continuous energy required to sustain a physical identity across successive projection steps. Mass and energy are revealed as two distinct states of the same underlying coherence field, traded at the geometric rate of c². We establish the conditions for massless propagation by setting the lock potential, lambda, to 0 in the free field wave equations. This isolates the basic observable event, a scalar emission unit, or SEUK, which is a localized coherence resolution event. Under ODTBT, light manifests as a continuous chain of these successive SEUK emission events. Because the lock potential is 0, this sequential propagation occurs with 0 recursive overhead or drag. The speed of light is the maximum resolution frequency of the coherence field, the limit at which these events can physically resolve within projected spacetime. The mechanics of this propagation map exactly to classical electrodynamics, following the correspondence established in ODTBT Addendum 14. The classical vacuum constants of permittivity and permeability find structural origins in substrate properties, epsilon rec and mu rec. Epsilon rec governs the substrate's capacitance, determining phase strain accumulation per unit of coherence input. Mu rec serves as the substrate's inductance, or resistance to torsion memory discharge. These properties determine the emergent value of C, which equals 1 divided by the square root of their product. This product establishes the substrate's absolute information delay per unit of spatial propagation. Light travels at C because it resolves coherence with 0 recursive overhead. Matter moves slower because sustaining a stable identity requires continuous lock energy. Moving from massless light to massive matter requires a topological mechanism capable of trapping coherence. This occurs in the zero deviation valley, or ZDV0, a basin attractor that requires continuous recursive energy to maintain identity across projection steps. We define the coherence density, ρc, as the recursive energy stored per unit volume to maintain this lock, balancing phase strain against curvature retention. Multiplying this coherence density by the effective projection volume yields the total rest energy. This identifies mass as the coherence density integrated over volume, related to energy by the factor of c². Mass is coherence in a locked configuration. Energy is coherence in a released configuration. Inertial mass and rest energy are identical physical quantities, expressed in units separated only by the exchange rate of the projection geometry. This leads to the dimensional question: why must this specific exchange rate be a velocity squared? The ODTBT framework provides an explicit structural breakdown for this conversion factor. C represents the resolution rate along a single spatial dimension. Energy density involves the product of two field components, each propagating at rate c. c² is the 2D geometric footprint of this dual component field, the area element of projection geometry. The conversion between mass and energy requires c² because energy scales as the product of these two components. Reintroducing the lock potential allows us to calculate the dispersion relation for a massive object in motion. This mathematically resolves into the standard relativistic energy-momentum relation. The lock potential barrier lambda from the ODTBT Lagrangian is the direct structural origin of the mass term. This suggests that the mass spectrum of elementary particles reflects the varying depths of specific ZdV lock potentials. These substrate mechanics generate the geometry that special relativity describes, confirming its results while providing a mechanical foundation for them. Proposition 6.1 suggests C is not absolutely invariant. It remains invariant only within a fixed coherent state of the local substrate. Configurations that modify the local substrate, such as strong laser fields or high recursion depth states, should produce measurable shifts in the effective propagation speed of coherence events. This identifies 4 core conclusions. C is emergent, mass is locked coherence, c² is a geometric area element, and C is substrate relative. E equals mc² reveals a single physical substance, coherence, in 2 distinct states. Mass is coherence in a locked, identity-sustaining configuration. Energy is coherence in a released, propagating configuration. c² is the exchange rate set by the projection geometry's maximum resolution rate.